Yeah, so I just need to do the whole pattern to hold these. So I got a 4 3/8, 4 3/8 by 4 3/8 square to accept the hardware fasteners for this particular bearing. I think I just chose, I'm going to use 7/16 hardware. It's a little bit of oddball, but it's not totally, I mean, 7/16 hardware is available on most shelves. Half inch and 3/8 are way more readily available. It's just a more common size of fastener. You might not know this, but I know this from a little bit of experience that a 7/16 fastener is just a little bit odd, but it's not totally, you're not totally having to order it online. It's going to be available at your local supplier that carries hardware for sure. 7/16 is common enough that it's stocked. Problem is it's really close to half inch and it's really close to 3/8. And so it's kind of an odd size that, your maintenance techs are going to be like, gosh dang it, these like here I've got all my hardware to go to town and or my I've got all my tools and here's a flipping 7/16. It's not the end of a mechanic can that's nothing to them as well. If you're disassembling car components, you're gonna have your whole tool laid out to take apart all kinds of fasteners. But it is something that I'm at least aware of. What is my hardware? Is it available? Am I designing something that is causing someone to have to order parts from overseas or something? That would be bad. So the awareness of what's available on the shelf will come with time for sure. But so I'll say 7/16. So I'm going to kind of get ready to do like a threaded 7/16 through my end plate. So I'm going to come back here to my so I've kind of evaluated that back to my solid. I'm ready for a whole pattern. Um, and so I'm going to say that my it's a rectangular. I'm just going to use a rectangle, and it's 4 3/8, 4.375 by 4.375. I'm going to use the points on this geometry to be your whole pattern will work off of points of geometry as well. Your whole command, I should say. So if I say this is the size of the whole pattern for the bearing, 4 3/8 by 4 3/8 to center of hole. And I just need to locate that centered over the center, right? So I'll use my geometric constraints here. And you'll see me do some funky things. Sometimes the way my mind works, I get in here. I think when I did the last, anyway, sometimes I do construction material and I use that. Sometimes I just use the geometric constraints. So I do different things depending on how my mind is working that day. But I mean, when I previewed the video from yesterday, when I looked at me drawn, I was like, well, I could have done that. Why didn't I do that? And then it just doesn't, I don't know. Some things just don't dawn on me. But this is my horizontal constraint to center of my 4 3/8 and a vertical constraint to center of this somewhere to that. That freed me up from doing a bunch of different construction geometry. But technically, this to me is this particular rectangle that I put on, which I'm now holding down shift and selecting it all. I'm pushing that to construction material. What I want is the point. What we'll be able to use is the hole command on the points is where the holes are located. So to me, this is right now a pretty good finished sketch ready to extrude as an end plate that's a 1/4 inch thick. That is in our diagram as well. Our flanges are 3/16 on the housing, but the end plates will be 1/4 inch material, a little heavier duty. And so I'm going to say finish on this. Th then I don't know. It could just mean that you've got some constraints already established. It didn't allow you to do what I just did. I am. Yeah, I'm definitely picking midpoint as a selection. So you're right. If you're picking a horizontal constraint and picking a line, if it's already horizontally constrained by the way you drew it, like a rectangle that I drew, it won't allow you to apply that. But I am picking midpoint of that line, which is what. So when you see a sketch like this, that's kind of an indicator that something's been constrained to the midpoint there. It almost like kind of highlight. It's a subtle thing, but once you get used to inventor's way of sketching, this kind of stands out to me. If I ever went to try to move this in my sketch, this would stand out to me as like there's got to be a constraint here because when you do those geometric constraints, they sometimes it populates those little dots like that. Did that help? Did you get it, Lydia? Oh yeah, cool. Yeah, it probably just it didn't selecting the line wouldn't have been the correct selection there. It's already horizontally or already vertically constrained, so it's like you're trying to over constrain geometry. You get that a lot, I get that a lot myself too. And this is it. And I'm out of my sketch now. I'm ready to extrude this thing. So yeah, I'll just extrude my end plate like that. And I just need to extrude it to this plate thickness size here. So this is going to be 1/4 inch thick, 0.25. And so that's going to be what the end plate looks like. Eventually, we'll bend some flange returns on it to stiffen up those bottom and top edges and to make it a really stiff, structurally pretty sound end plate here. So I'm going to say okay on this, and then I've got to go through and put my holes through. So I got to turn back on my sketch. Uh, 1/4 inch, 0.25, and I extruded it away from this because the end of my solid as it is the end of the housing inside, and so this is the uh, this is the bolt-on end plate. So I've extruded it the correct way. And then I'm back into my sketches here now with my sketch turned on. And I'm gonna go ahead and do what I've got is I've got a sketch that has points and points of geometry. I'm gonna have to use this a couple times to make the holes. They're not the same kind of holes. The holes around here are going to be the same as these. So these exterior holes are going to be these holes. So if I go into my hole command, I might have that already loaded. I don't know how mine recognizes all 8 points right away. If it doesn't recognize 8 points, you can always go through here and select them, right? Like there's that one, there's that one, there's that one, and that one. Just make sure it probably won't recognize the ends of that geometry for the bearing one, but there's 8 positions that I want to make. And then just make sure it's just a clearance hole with no seat. And then I kept it on the ANSI unified screw threads. And then I had to come in here and say that this is going to just be a hex head bolt to bolt these two together. And the size will be 3/8. And I'm gonna choose the normal fit as well. And then I just need to select my surface and where it extends through. If I said through all here, it would definitely probably be sufficient because I don't have any fear of cutting into the solid anywhere else. So through all is good. And that's my whole pattern for the bolt on. I'll say okay. And then I want to do the other, I want to use the whole command to do the threaded features uh, for the hardware that will hold on the bearing itself. So what I'm going to do is choose my whole command, and that's kind of buried in my sketch here. I should be able to kind of hover over this and select it. I mean, I assume we could turn on like 2D geometry, or you could change your view style. You might not do this a lot, and I don't do it a lot either, but you could change your visual style to something that you could maybe see. If you change it to this, there's the geometry. So, some people will do this if it helps to see through the solid. I could turn the solid a little more translucent to see, but I just turned it to a 2D sketch here, which I don't do often. But when you have your sketches buried, maybe it helps you to see this because what I'm looking to do is do a hole, and it doesn't really have anything selected because it doesn't know. But I'm pretty sure I can pick these as where my hole points are here. The end, like the corners of geometry, work like a point does. And so I don't know if we've used that method before, but it's those things. Of course, it's preloading the last hole that I use, and I've got to change this because this is obviously not what I want, but those are the locations I want. And what I want in this location, though, this is actually going to become a threaded hole. So this is what they call a tapped hole, not a pipe tap. This is a tapered tapped hole for more of like a pipe thread. Pipe threads are tapered in case you ever have done any kind of pipe, like threaded pipe connections. They're tapered so they kind of like seat eventually and seal better than just a tapped hole here. So for regular bolts, regular fasteners, and for what we're going to use in the end here, we're going to do a tapped hole and with really no seat at all. I just want a through hole that's tapped. And it's going to be it kind of recognizes, it's funny that I don't know why this auto-populated. That's actually what I want it to be. I'm not sure why it chose that, but I'm going to stay on the unified screw threads here. And I do want it to be 7/16 because I don't want it to be 1/2 inch. That's what the hole is in my bearing. So a 1/2 inch fastener would be too big. 3/8 fastener is too small. It's the Goldilocks case. I'm going 7/16. It's the one in between, just right. Although I think Goldilocks was always the little one that was just right. Moms and dads were not good. Okay. That doesn't matter, but it kind of does. Let's see here. I go off on weird. Okay, so 7/16, just right. And then that is a 7/16 14. That is a unified national chorus, if you remember, which is a really standard bolt. Um, there is a fine version, probably a unified national fine thread. These other ones would be even different here. The two that I would either have selection of is either a fine thread or a coarse thread. I'm going to choose coarse unless I have a really good reason to choose fine. And so a unified national coarse is going to be what I choose, which happens to be 14 threads per inch is what that 14 means, right? Back to our old days of fasteners. So this is the type of fastener I want. This is a little bit more standard. Fine thread being for specific applications, maybe. 2B, yes, that's great. 2B or not 2B. I want a right hand thread for sure. I'm not gonna, left hand threads are odd in the fastener world for sure. Most common is right hand threads. If you think of righty tighty, lefty loosey, that comes from a right hand thread. If you ever learn that phrase when you're putting on stuff, righty tighty, lefty loosey, well, that works great on a right hand thread. If it's a left hand thread, it's lefty tighty, righty loosey. Usually they reserve that for situations where I don't want this to be uh, I don't want the wrong fastener to go in there. And so I'm almost going to prevent that by having a left-hand thread. So sometimes I use it. I think sometimes in designs they use it strategically so that right-hand stuff cannot go in there, or that you couldn't apply the wrong bolt to that. Uh, but it's pretty rare to see left-handers, I think. Behavior, I just want it to go through to I want to choose where I want it to go through. So my sketch is on this side of that. So I'm just going to say to next here and maybe choose this surface, which should allow me to do something like that. Is that kind of how I want it? I want it to be through though. It's actually wanting to set it to a drill point angle. I want to say flat through. I don't want it to put an end or like you almost want like a drill point end of a termination is maybe for a blind hole where you aren't going all the way through the material. And then we have what, a flat W, a flat angle V. So I'm just going to choose the most simplest right here. So this should be all the way through, and then I'm going to say OK on this. And then I'll turn this back to, oh, my view. Just turn it back to my shaded with edges or something. Yeah. And that's just showing like it could be arguable, do I put that kind of detail in my solid model? Maybe not. Maybe I could just have the points ready to make this in my actual parts, but this is what you're going to do. And if it's already in the part, I think I may have to reassign the threads when I create the part from this. Remember, this is just kind of this base component part, but those are going to become threaded like that. And then and then we'll have to create the part that threads into that. And then it was going to weld on the inside and become this kind of permanent fastener. So there's no head of a bolt on the inside of my conveyor. So yeah, yeah, for sure. Yeah. And th this end plate is done and it's ready to be bent. And then I'll just have to pay attention to how the bends turn out when I get there. But it needs a place to bolt onto, so there's nothing to accept it. So to me, the last part of this is to kind of create a flange like this that comes in right here and matches, and then one over on this side. So they're not like connected to all. They're kind of these individual parts that will be welded to the housing solid. So I'll come in here and make those, and I can make those from the same plane that I made this, or I could use this. I could use a face surface here to make it. Um, yeah, however I want to do this. I might just draw this on the same plane that I drew my end plate from, which is the end of my housing. I'm going to go ahead and turn off this sketch. I've consumed everything on it that I need. And I'm just going to start a new sketch for the flanges that bolt onto it. And I'm going to use the same surface that I created that original end plate from. So that's the end of my solid. And I can go an F7 to cut to my graphics here, except for I need more than that. I am going to match this. So some of this I can use. Really what I'm looking to do is build a flange here that matches this. So this is a good place to project some geometry because I want my flange to be pretty much matched this edge, right? It's going to be that. I want it to be no longer than this bottom edge here, but I might have to be careful with this projection and make sure and double check it to my other solid or my solid. But what I'm looking to say is, okay, so that's as low as the end plate goes, and then this is as tall as it goes. And if I could build these as two individual parts, or kind of two, I could build both sides at the same time while I'm building it, I guess. So there's really, I could have selected the whole surface that I projected. But there's the whole surface. I might keep these as solid lines because I might just incorporate them right into the solid that I extrude here. And then I just need to like know how wide that is before it hits the housing, right? So if I just unslice my graphics, there's my housing. And what I need to be aware of is how this is going to fit together. Like we're kind of looking at fit here a little bit. And I don't have to get it perfect because I can adjust it later when I really look at my parts. But what I do need to know is kind of where this terminates because I don't want this flange to be this. I need to remember that this gets skinned with 12 gauge. So I'm going to need to come away the same way we came away here. And usually really using the same dimension. This would be another one that I'd like to map back to that original dimension at some point in the design process later. Right now, I'll just use it as another drawing, but what I'm going to do is project this geometry. This is if I made it fit right to my solid, it would be like right there. So I just projected that in there, how it crisscrosses there. I'm going to do that over here, choosing that edge there. And I get those two little rectangular boxes that are almost extrudable right now as they are. And what I can also put in them is these. I can actually project this geometry. So, I mean, if I ever change the whole pattern in the end plate solid sketch, this should automatically update because I'm just projecting its geometry. So it's not like I'm recreating it, redrawing it. Nope, it's just projections from what I already did. So those two pieces are pretty well close. I just need to come in here. I'm gonna slice now, F7 slice again, because this is not the true location of my flange. That would be right up against my solid. What I need to now do is create let me zoom in, create an offset that's going to be that space of the thickness plus the 30 thousandths is what we did, right? That's what we did yesterday. I don't want it to be a size on size fit necessarily. I want a little bit of room. Yeah. It is going to weld to that skin of the housing, but a little bit of room is helpful even in that setting. So what we do is offset that. Offset this. Yes. The thickness of 12 gauge, which because we pulled it up yesterday, I have it memorized, right? It's like 0.1094. Everybody has that memorized. Come on. That was 12 gauge thickness from that sheet metal gauge chart that's in the resources section. It's also, those decimal equivalences are in kind of my SEMA manual standards towards the end of the PDF document. There's a bunch of like material specification stuff. There's pipe sizes down in there. There's sheet metal sizes. I like my other sheet metal gauge chart better that's in our resources for this assignment, but and then what we did is I said, that's fine. And that would be at least accounting for the thickness of the material that I'm going to skin this with. But I added my 0.30, my 30 thousandths to that dimension. These are situations where I do like to make sure this is a point, right? Oh, I have a double decimal there, but so we're kind of like building in tolerances. This is kind of unique. You could work in a system where they're like, we're going to apply the tolerances to I don't know, like I'm actually making my parts so that they will be the correct size when they're laser cut and not have to like and assume a tolerance on the laser cutting necessarily. But there are times when we actually like will model to exact size or theoretically exact size, and then we will use our tolerancing on our drawings to apply the correct tolerances, right? So I'm kind of always like crossing that fence with my design. Sometimes I'm drawing to what the actual part size with my tolerance, like that's kind of what I'm doing here. I'm building a part with tolerance applied. And so sometimes I model like this, and sometimes I model right to the true thing, and then allow my tolerances in my drawing dimensions to control real part size. So you have to kind of blend those two as a designer, knowing when to apply that characteristic and when to maybe build parts with tolerances built into them. So this is tricky to know when to do what. And it's only on my experience having worked with parts like this that I'm like, I'm going to apply a 30 thousandths like clearance to this. So, and then I actually dimension mine that way. So I'm seeing my thickness when I come into this dimension on my sheet. If I ever want to like analyze what my clearances are, what I'll do is I'll pop on this dimension and I'll be like, oh, it's the thickness of I will be able to tell because it's you get pretty intimately involved in these models as you build them. that once you come back into it, it's pretty obvious to me. I'm like, oh, 1094, that's 12 gauge thickness plus my, it looks like I'm creating 30 thousandths of clearance. So to me, this is a situation where I wouldn't want to add these together as one dimension. I like to open them up and see that I've done some manipulation here when I'm analyzing my model. In case like 3 months later, I don't know what the heck I did here. I would jump into this dimension and be like, oh, I see what I did. I'm building in some tolerance here. And so long story short, that's how far off I'm offsetting that and here too. So it's going to be the same thing. It's going to be I can just drop it anywhere here. I don't care what that dimension is. In fact, actually I should have had to put that dimension though, because we want this dimension over here offset to be the same as this. So I'm just going to drive it from this dimension here. Yes. And here's my sketch. Oh, it's point. The way I've typed mine in is kind of specific. It's 0.1094 plus 0.030, which is 30 thousandths, which really matches what we did on the lower flange. It's kind of the same, which is when I could really go back and refine my model and put both of these dimensions driven by that one dimension from the bottom flange. But I'll do that later. That's design improvements later. So check this. Now I've just made these the same, so they're actually now there's only one dimension in this sketch here, really. It's all projections in one dimension. So these get buried though, and you can move these if this kind of helps sometimes. If I get into this sketch, I may want to see it as see it obvious here. I didn't turn as much into construction material here yet. I'm just going to leave it like that, and I think I have the profile that I want to extrude is now pretty much boxed in, closed geometry. If you ever wonder if things are closed, like I've showed a few of this when we're troubleshooting when something won't extrude, you feel like all of your lines overlap correctly and that they should be extrudable. But then when you get to the extrude command, it's like, I don't see any closed geometry to be able to, to extrude. If you ever have that, sometimes the way I will troubleshoot a sketch is because these aren't technically joined necessarily, but if you this is method, like if I select geometry and right click, there's this close loop command that is really handy for troubleshooting what is not connected in maybe some polygon that I'm drawing that I want to extrude. I need to make sure that I've got, you know, however I draw, the lines can overlap each other. That's good. If they just fall short of each other, that can be a problem. And it can be such a small thing that you didn't see, that you didn't constrain at 2 points together, right? And it can be hard to troubleshoot. If you use this like closed loop command, it'll be like, okay, select a curve that is connected to the end of this open loop. Continue selecting curves until the loop is closed. So this is how I would troubleshoot something. I don't have that trouble now, but if I wondered if this was actually connected to this, it would say, oh, there's a coincident constraint required. Would you like to do this? Sometimes it'll help you. Sometimes it'll help you troubleshoot where you've got some disconnected stuff here. Like I don't know if I really need to do this. I'm going to say no, or I could say yes, and it will apply a coincident constraint there. And then if I select this geometry, it'll be like, do you want us to connect these? Maybe yes, I do. Or and then it won't let me, but I'll be like, okay, I'll just move on, and maybe I'm going to go around this side. But what you're doing is you're looking to see if you can if these can be kind of joined together, and then it's going to say it doesn't need to be done there. So all it did is it applied a few coincident constraints. And what it did is I think it moved this line to terminate on this line by closing that loop. So that is how I troubleshoot geometry that I should be able to extrude. The way I sketched it, it should come together. And it didn't here. So I should, and it can just be hard to tell if these overlap and are where I want them to be. But I think I'm just going to do that again here. Select this, say close the loop. It's just going to help you troubleshoot as you click around this a little bit to close these loops. Technically, those probably didn't have to be constrained that way, but that's probably better if they are. And then when I finish this, so just use that. Remember, that's a tool to check your geometry, and it'll help you identify where things do not crisscross correctly. And sometimes you still can't find it, but I just exited that. This is what I want to extrude. So I'm just going to do my extrude right here. These are 7/16. I'm not going to extrude this as a cut. I want this as a solid. So then it kind of reversed direction on me too. I thought I might want to cut mine, but it's actually that I want to match that. So that's that. Only I don't want it to be 1/4 inch. the flanges on the housing will be 0.1875 or 3/16 of an inch. And that'll match this one down here. So there's just kind of using, yep, that's good. And we can do it, we can do this, I think in the same moment, we can do this as another profile. I'm still selecting profile, so there's that one. Since it's going to extrude the same way, I can just bundle it under the same feature. And this thing is ready for skin to be on my solid and to accept this end plate flange bolt up. I may, once I make this out of metal, I may come in here and evaluate some of these gaps that I'm showing here. Remember, this plate is going to end up having kind of a curve and a radius and a flange that returns when it gets bent. So once I do that, I may come back to this and decide that I don't want this to sit up, or so I'm going to say okay on that. Ooh, and I could probably make that. Let me show you one thing. I'm going to go back into that extrusion because I kept it as uh, a joined solid. In this case, I might say, we'll make these a separate solid. They'll stand out from each other and they won't blend together. So I'm going to say if I click this is make it as a new solid. And all it does is going to populate more than one solid body here. And I'm just going to say, okay. And then it kind of resembles more of what it will. It crossed my mind that I could have done that with this, like the initial discharge extrusion, because the way when we go to make this part, this gets a little complicated here in how the options I have to make these parts. It's probably going to be helpful that I actually, and we'll troubleshoot this later, but that I maybe wouldn't have blended this solid in with that one, but it's going to blow up our sketches. I already checked this later, actually, or earlier. And actually, I made this discharge different in my original. If you've pulled off the model from Canvas, which is this one, and taken a look at it, you can see that I have a line here, which is actually going to be helpful. I'm going to put a welding seam on this line. So when we actually skin this thing, we're going to be like this and this little part right here and this part. That'll all be one piece that gets unrolled in the sheet metal commands. But it's not going to let me unroll. If I connect this part to it, it's not going to let me unroll it. And so I'm actually going to make this part and this part and this part kind of be this like C-shaped piece of metal that will lay flat and will be like three-sided. And then my weld seams on my housing are going to be right here. They're going to weld together right here. And then I'm going to go down and along here and weld those together. And then come back up here and weld this together. That's how I'm actually going to attach my discharge chute to the housing. But in order to do that, I kind of need this seam here to kind of work from it because it recognizes these as two different faces in my solid. If you come back to mine, the way I built it, and the reason is because when I did this extrusion, maybe I was already thinking that a little bit, or for whatever reason, the way I saw geometry when I did this one, when I did when I did the discharge chute extrusion, you can see that it's a different sketch than I used on ours. It's actually been drawn from the end, projected, and then I extruded it that way. And so I ended up naturally building in a seam there. But it's not the end of the world. I'll be able to work with my solid, and we'll just have to be aware of how I want to break up the part and how I skin this solid that can be a makeable part. That's going to be a big factor in, you know, anyway, in sheet metal, it has to be able to unfold and lay flat. And so you can't have like geometry that you're trying to include that's going to like mash into itself when it unfolds. It takes a lot of using sheet metal to kind of get that philosophy, but you can just see I used a different sketch. The way I built this in my original solid is different than we've done it now, and that's normal. I mean, I'm not really super like trying to copy that. You you can follow that model pretty well, and it should get us to about the same place. But I'm kind of really happy with my discharge end right now. Um, this is going to get bent and then it's going to get a hole pattern from this solid. So I'll be able to, this is going to be, this whole solid is going to be the base component for this end plate. And it has a sketch that has right there is going to be the whole pattern that eventually I'm going to put in the flange return that I'm going to bend on that part. So I'm going to have a sketch available to me to use later down the road, which is why I built that flange that way. But so it looks unfinished, but it's because I'm already planning on using sheet metal bending features to finish out the part. And so that I'm ready to move on to inlet housing. And I think I can get a little bit started and call it a day here in 15 minutes. But so let's go. I got to go peruse my manual, but that thing is ready. And I'm going to go to this end now. Yeah, the critical thing to see there is when you're in that edit the feature is I made it a new solid. So I chose to do those particular extrusions as their own kind of solid. Um, and I could have chose to do one side as one solid and one side as another solid. Here I did them as just kind of one solid, even though they're totally not connected to each other. They're kind of on each side. But yeah, I just selected this little thing here. And then it doesn't blend them together. Um, and it's okay. Like what it does is it creates two solids here now, right? Here's one, here's solid one. I could have done that with my end plate as well, actually. Um, but and I can always go back through and go to that extrusion and say make that one a new solid too. So sometimes I do some of these modifications later. What I didn't like to see is if I didn't do it, it was going to blend those together and I was going to kind of lose this seam that I like to have here. Sometimes I use these solid seams strategically for sheet metal part creation. And that's kind of that's why I went off on this tangent. Mine doesn't have a seam right here that I actually am going to want, uh, but I could actually still use this face to create a thicken at the thickness that we're going to do once I get to that part sequence. And then I can actually cut out what I don't want on it. So I can still modify this even if I don't have a seam on my solid. I can even probably modify my solid to put a seam there that will break up that face. And because I have ways to split, like split a face here. So I could actually come in and just put a seam here that will break this particular surface up into multiple faces is what I'm gonna want. So, but we can troubleshoot that when we come back into the part creation. Let's go back. I just need to let's do some modeling on this discharge end now. So I have to reference my manual a little bit here and this one here. And it's towards it's in the latter part below the housing. Is where we have those there's the shrouds and covers, but below that is supporting feet. Okay, great. Here is the feed and discharge spouts, the one we used quite a bit yesterday. I haven't used it much today, but discharges we've already kind of taken care of. We've put ours to the flush with the end plate. Here is the inlet, some dimensions for the inlet side of things. And I think on my inlet, I kind of slammed it to the very end as well. So I don't have an inlet necessarily like this that comes in a little bit and then lets stuff fall into it. I think mine is incorporated right into the end plate. Let me just double check my solid, my original one here. Yeah, see, I'm incorporating it similar to how I did the discharge, like a three-sided flange. The other flange will be bent into the end plate as well, even though this is a circular end plate with a circular flange. Um, Almost the reverse of what we've done on the other end in some ways. And so I think this dimensioning is in that manual. So I'll start with this extrusion here. So let's go back to that manual. This R dimension is what I'm kind of looking for. This is if I zoom way in here, this is top of my housing right here. It's a little confusing on what my hidden lines are, but it's almost like it's a little confusing actually. It's almost like the lines don't line up with the image so much, but R I feel like is from the top of my housing up to where my flange would be. And I think it's not a super long dimension, but that's an extrusion I could kind of do um, kind of from the center plane like I did my other one. Let's see here. Or I could do it right from the top surface as well. But what is R? R is 2.25. So I read that out as like over on mine, which doesn't have anything yet, is like 2.25 from this surface up to where the top of the flange, where something is going to bolt onto it as well. It's kind of like the discharge. They're going to let me build whatever I want to feed into it, whether it's a chute feeding into it or some. Ours is going to be an even flow bin, a small little bin that'll hold a little bit of product. Um, and so I just want to extrude from there. So I could draw that sketch from here, from this surface. I could draw it from the center plane like I did on the original discharge. Um, Yeah, I don't know how I drew it over here. It looks like I do have separate solids, kind of separate faces here as well. Um, And I don't know if I incorporated those face into the side later, but yeah, it looks like when I drew this one, it's probably some inlet extrusion right here. Looks like to me, maybe I don't know if I created a work plane. Actually went here and did that way. I'll probably do that a little bit opposite of here, but and kind of do it like I did on mine. Not that it's better or not, but I think I'm going to just draw on this top surface, new sketch, and use this as my projected geometry, the overall edge here, the overall side. And then I'm going to use those as constructions though. And I'm going to place just a rectangle that I can extrude. So let me just check the sizes of that. I know that it's going to come up that 2 and 2 1/4 tall in the R extrusion length. But what is its overall width? Well, I think it's maybe documented here. I don't know. I think it matches this. I think it's a similar size that I have here, 11 by 11 on the ID, which is what A was, right? A is 11. I think it's the same size because they don't have a separate, these are discharge only here. They don't have a separate sketch for this profile. So I'll double check mine, but I think I just made it 11 by 11, I'm going to guess here. I'm pretty sure that from here to my end is 11 inches. Yeah, 11 by 11. So it's a similar extrusion. And then it should be, to me, it should be 2 1/4 from there to the top here, 2 1/4. Yeah. So if I back to my other one, I'm going to just drop in this rectangle. I'm going to snap it into here. So I constrain it to that point, and I'm just going to build my rectangle this way. And I can snap it into here. I can also tab over and say it's 11 in that direction and tab back. Let's say 11. So there's my geometry constrained. And then I just need to extrude that thing 2 1/4. Extrude it up. I can maybe put this as a join solid or a new solid. Maybe on my other model, I did a lot of like just new solids and created those seams. So I will come, yeah, maybe it says, do you want to join to that solid? Now that I have multiple solids, it's going to ask me to kind of like select the solid that I want to connect it to. Even though things are disconnected that seemingly should not be connected, it'll allow you to connect it to those solids as well. So it's not necessarily smart that way, but this is 2 1/4. If I say okay, that joined it to that solid. And I could come back and have the same I kind of did it this way just so it kind of matches what I did this way, where it's joined into this. And if I have to come back and create a seam here to break up my face, I may have to come back in here and create a seam to break up my face too. Or maybe this face could be incorporated into the side skin. So it's just something to evaluate when we get to making sheet metal parts from it. But at least there, I've just done it as a joined solid again. And now we're ready to build a flange on that. And I think it's a good stopping point. But that's my next step would be to build a flange. And really, I'm really going to probably copy the way I built this flange because it's the same shape. It's 11 by 11. It's going to be the same hardware to bolt it on. And so I could probably like copy that. Let me just do one thing really quick and see if you've never done this. Sometimes it works for you, sometimes it doesn't. But can I copy that sketch to a new sketch and then can I just like rotate it in to be how I want it? Sometimes it's a bigger pain than it is just to build it from scratch, but there are sometimes when I've done a really intricate sketch that I just copy and paste into a new sketch. And so I might just try like one shot at that real quick and say, this flange, I think I'm going to use this as my face surface to create this new sketch. So I'm going to create a new sketch. And there it is. And maybe I'll just finish it for a minute and jump out of it. I didn't have to create it first to do what I'm going to do, but there's my new sketch ready for some data. Here's my sketch that really contained the flange detail that I drew. So if I come in here, I think you can just say copy this sketch. Maybe you have to go into this. Oh, just copy it right here. This is copying that sketch. Now can I go into this sketch and edit this sketch? So now here I am on my sketch, which would be right here. And I'm going to say right click and paste. And it does bring it in. It just doesn't constrain. It doesn't know where I want to put it. So now I can try to move it carefully, try to move all the geometry at once and create some projection geometry on this. Because this is a symmetrical flange. So really, and it even kind of is oriented maybe how I want it. Like if I can just slide this thing over and get it constrained right, this might work for me to create my next flange. So I just need some projected geometry to constrain it to. So I feel like I can just use this this is my projected geometry. And really what that resembles, I think, is the dashed lines, right? That was original projected geometry. So I'm going to maybe turn these into constructions as well. And then I'm going to try to move this, but I'm going to do it as a whole group. I think I'm going to mass select this thing and I'm going to say move. Usually it's going to want to know a base point to move it. So I'm going to pick something that I can locate like this, like just a point right here. Base point is this. Now I've got a hold of it. I'm going to try to place it on some projected geometry that I can snap to like that and just say done. But it doesn't mean that it's necessarily constrained there. I've moved it over there. Now I've got to start flexing it and seeing what I've got to constrain to put it here. So like I said, this can be helpful, but it can kind of be a bigger can of worms than you want to deal with, like reusing a sketch. But I don't know, it's worth a try. It saves a little time here and there. You just got to kind of carefully uh, like see what shifts. Like that's going to allow that to shift that way. So I've got to just be careful and say, well, I don't want that. What else can I constrain? Well, you can start just doing geometric constraints to lock it into. I've got it moved into that position. Maybe it doesn't, it didn't already, it doesn't necessarily carry its geometric constraints over with it. So what if I apply that? I'm kind of applying these. I'm kind of working from the inside a little bit here. Just making sure I'm going to keep these sides here like vertical and horizontal. So I'm actually applying a couple vertical and horizontal constraints to the inside flange profile. It's just something I've chose. Kind of work from the center out a little bit here. And so those are good. This here, I might need to constrain, I don't know what, something. Like you can see my lines, my construction lines will break away from this and change the geometry. So I might need to pick like a point on this line and constrain it to my new projected or use this projection. It's almost like I don't need this as much because I already have it on this, but it's like I need to reconstrain this stuff to my new projection. So this is where it gets a little complicated. I flex it every once in a while, and then I'll undo that so I don't move it out of a weird alignment that I'm not ready for. But yeah, like if I delete this, if I delete this line. Anyway, sometimes I have to troubleshoot. Maybe I don't want to delete that. Maybe I just want to try to do some coincident constraints. And if I choose, I don't know, let's see. I'm going to say that I want to delete that geometry. It might not let me delete some geometry. Definitely doesn't want me to delete that geometry. Oh, that's good. I'm starting to move it in the right direction. All I did was I'm constraining the dash lines from the existing sketch into the projected lines that I projected. So I'm kind of pulling them away so they flex. This can blow up on you in a hurry, honestly. This is when it's kind of easy to mess this up. You can see that I'm getting some stuff kind of out of whack. Stuff is starting to get constrained, but I got to make sure that I don't want that thing to ever have leaned over. I thought I already placed a geometric constraint on that to keep that straight up and down. That helped that a lot. It looks like I've lost like these two being constrained to each other. I'll come back to that in a minute. And then I'm going to do maybe another coincident constraint. What I've done is slightly flex this away so I see those lines break up, and I'm going to say constrain that. to this, and it starts to as I've almost fully constrained it with just a little bit of movement. I want to be aware of anything that's floating out here that isn't constrained and wonder what the heck that is. But I think these two are they just don't know that they need it to be constrained to each other, those two crosses. So all I can do is choose like this point and this point. I mean, yours could have broken up different than mine for sure. And I still have this one floater, which I don't know what it's for. Sometimes I'll just delete it first and see what it blows up. And maybe it was just a point that was carried over from that sketch. But I think I was able to get it. I mostly constrained my incoming construction material lines to the projected lines that I had. And so I've really got overlapping kind of projections here. If I change stuff, this one could blow up on me a little bit. Having been a copy and paste sketch, it did save me a lot of like work. And I feel like I feel like I didn't lose it as far as 5/8, 5/8. I'm seeing the same numbers show up. Everything looks constrained again. 14 and a quarter by 14 and a quarter. I've got this how it came into my sketch land. It came in correctly to where I actually have this broken up to where I just want to extrude that shape, the U shape around here again. Reverse of that. So this turned out to be good. Sometimes I have to bring in sketches and try to rotate them. That gets ugly. Usually I'll try to do that rotation out here before I ever bring it into some geometry that I'm going to try to snap it to. But yeah, I mean, it's just that when you have a really complicated sketch, can you reuse it? Sometimes the pain of reconstraining it is worse than recreating it. Sometimes the pain of reconstraining it is saved a bunch of time. I feel like in this case, it saved me some time. So I'm going to say finish, and then I'm going to extrude this. You might not be at this point yet, but I can try to help you if you tried to do what I did. You could also recreate it from scratch. It's the same sketch, but this is what I want to extrude. Um, but I only need it to be 0.1875, which is 3/16. I want it to be the other way extruded though, because it's going to slip on the housing here. That's going to be the flange that gets welded. This gets to be a pretty tight little corner here. Somebody's going to have to come in here and like weld across. These flanges are going to be welded onto the sheet metal of the housing, and this is one reason why you have to be careful. Like one reason why our manual helps us is maybe this 2 1/4 that they have here gives me enough room to apply, as a technician to weld in here, flange to housing. If you go down lower than an inch, you're really I mean, this is already kind of a hard to get to. This is kind of a fillet. This is going to become kind of a fillet weld. Sometimes when they do flanges to housings, they'll do like stitch welds where they do intermittent welds around it. Sometimes in some processes, they need to be seal welded. And so either way, you start to look at designs as like, did I just build something that someone can build or not? And this is a tight corner to get into. And it's really the best way to get into it is when you flip this thing upside down, which when people build stuff, they usually, if they're building in a shop, they have access to cranes and tools that can help them roll things around to get into best positions for assembly. But you could get some feedback from somebody that said, "Hey, can't you just make that inlet like 4 inches tall, and it's way easier for us to build, and it doesn't really matter. You're going up to a bin anyway." Like these are discussions that can sometimes happen after design has caused some issues on the fabrication side of stuff. You'll get feedback that says, "Hey, I know that that's the SEMA standard, whatever, and great, yeah, we put the littlest person on the planet underneath there to weld it, and it works. But if that guy quits, can you make it so somebody my size can get in there and weld it?" Yeah, these are things you become aware of once you start to learn how materials come together, and you can make someone's life very miserable, which is seemingly easy for me to. I'm like, I don't know, I just extruded. It was easy for me. They're like, yeah, well, it's harder. The virtual world's easier in some worlds, so I'm gonna say, okay, I didn't do that as a separate solid either, and I got to do the holes in it. And so I'll do that, and then I'm going to call it good. I just want to get the holes in it, and then I got to build the end plate for it on Thursday or something, and then we'll dang near be ready for at least some initial parts on this thing. So I think Thursday I'll definitely be getting there to my parts and some drawings. So stay tuned. I just won't get them done, but I'll get them started. So let's put some holes in that. I need that sketch turned back on, and I'm gonna Ooh, yeah. The way I constrained mostly once that sketch came in totally unconstrained is I mostly used the construction lines that were the dashed lines on the inside of everything. I constrained those to my projected dash lines, kind of on the points. I was using coincident constraints that, like, I chose the point of one line and attached it to the point of my other projected line. And I kind of did that like here, and I kind of did that here and here and here. And then the other things that I had to add were just some vertical and horizontal constraints to some of this geometry to keep it the inside solid lines. I had to apply those vertical and horizontal constraints to make sure that they didn't just turn on me kind of funny, right? But the way I explore that is I slightly flexed my sketch to see how it moves and to see kind of how to constrain it. That is hard. I'm going to tell you it's hard. Um, Using geometric constraints becomes more natural the more you use them, but they're tricky. So I was lucky. You might not be as lucky. Let me finish my holes and then I can come around if you're still hanging out and see if I can help. But because all I would do is come in here and say, do my hole command. I want to go back to a clearance hole. I'm not going to do all 12. I'm going to go ahead and selectively choose the ones I want, but I want them to be for a 3/8 bolt, normal fit through, and I'm going to select the surface as this bottom. My sketch is on top, so I'm going to select the surface to extrude through as the bottom side. But I need to select my positions, so I just want the ones that are, I go make sure I'm blue highlighted there to select that one, that one, that one. I don't need those other ones that don't exist yet. So I should end up with how many? 8 positions. Now it should let me choose the surface, that underside surface there. That was kind of critical. If I do all through all, it's going to like shoot those through my solid. If I had created a separate solid, I created another join solid on this flange, but if I had created as a separate solid, I think using the through all command, it'll only recognize that that's a separate solid. So there's a strategy to break up solids versus joining solids. I can't say I have the best strategy initially here, but that's a normal design process. Can be refined later. I'm going to say, okay, turn off that sketch. And if you need some help, I'll help you as I come around, but I'm in good shape. I got more done on that than I thought I would. If you've got your application for your test, make sure you turn it in to me before you leave.